All right. Thanks, everyone. I think today Lorenz is going to give a demo of the new visualization API that's in FastAI. So Lorenz, take it away.
All right. Let me just share my screen. I think you need to make me co-host or something. Allow me. All right. Yeah, that should work. Okay, can you guys see my screen?
Yep.
Okay, cool. Is it large enough? I can zoom in a bit otherwise. Yeah, today I'm just going to be showing a little bit the new visualization API that I've added to FastAI.jl. It's currently merged into master and will be in the next release. Like most things now in FastAI, it's built around the idea of different blocks. So a block is kind of a modality of data. So a block can be like an image and a label, and then you have a task learning to output a label from an image. That's classification, image classification, and it's based on the same principles as most of the rest of the library. And building it in this way just makes it possible to really use it at different steps of the learning pipeline, and I'll go into that in a minute. So let's just give an example. The basic, loading a data set for some task. Here, image classification. You can create a learning method. We know that's a method that takes the 2D image and outputs a string label. And we can load a sample from the data container using the data container interface from LearnBase. And then we can use show sample because this is just a regular sample. And then we can get this visualization. And the first thing you might see is that the default is not Markey.jl anymore for visualizations. Instead, it's this text-based visualization, and Markey is still supported. I'll show you down below. But Markey is now an optional dependency, and it really reduces the load times. If you load Markey into the session, it'll still use that. But now we also have this text-based view, which is also great if you're working in a REPL or a remote environment. It's just a little bit faster and supports that as well. It does look better in the shell where you don't have these white lines crossing through the images. But yeah, and then in the learning method you have these encodings. Like you crop the image, you pre-process it, you turn the label into a one-hot vector. This is what the encode does regular, just as usual. And then we can also show the encoded sample, which is an X. This goes into the model, and Y. This is what the model output is compared to, right? And by the way, we see that the image is now cropped, and we don't have a label anymore, but we have this one hot tensor, which is shown as a bar plot of probabilities. So these visualizations are all defined based on the blocks, and since for the method we know what these blocks are going to be at what step in the pipeline, we can visualize this. You can also see that this image is still shown as an image, even though the X is actually a image tensor. So it's a pre-processed image where the color channels are expanded and the values are normalized. And since that doesn't have visualization defined, this method automatically applies the decodings in reverse until it finds a representation that's suitable. So we have here this are the encodings applied to X. We start with an image, we crop it, we pre-process it, and you see here there's an image tensor. So we no longer have an image. And so what happens when we run show encoded sample, it looks at the output block here. This is what X is, and it basically just runs the encodings in reverse until it gets something that it can show, here the image. The one hot tensor, on the other hand, there is a visualization defined, as you can see, so it doesn't change that. We can also show, yep.
for the show encoded sample, is it possible just to like add the actual block that it came from? So like where it says X, you can add something that says like it was originally an image tensor, and then we mapped it to in this case, an image in order to visualize it, something like that.
Yeah, you mean to have that as a default behavior?
Yeah, because like if you do show encoded sample and then you see this visualization and you see an image for X, but it's actually not an image, you know, the actual data is not an image.
Yeah, I was thinking about that also to just show the block that it's actually from, if it's not changed. I'll show a bit further below how like the titles, you can customize those and create completely custom visualizations. But that's a good point there. Here we looked at visualizing a single sample or a single encoded sample. Of course, usually for encoded data, you have a whole batch. So this is, you know, axis. It's now height, width, color channels, and batch size is only a batch of 3. And we can also show that directly. Even though it's a collated batch, it handles that. And we can see then all these pixelated images of fishes now, all from the same class. And like the titles aren't duplicated, it's only shown once. Same, and then further in the pipeline, when you have a trained model, if you run access to the model, you get some outputs, right? So there's a batch of outputs, and then you can compare these to the actual input data using show output batch. You can also leave this batch away, and then you just this argument away, and then you're just looking at the outputs. But here we can see, you know, we want to see the image, what the ground truth is, and then this is just some randomly generated distribution of the outputs, just for show. But you can see we can compare, you know, and if this was data from a real trained model, then we would hope that, you know, this value is much higher than the others, so that it's classified correctly. And these show methods, these are basically the high level methods to use this new visualization interface, and they work with any learning method. So here we have a segmentation data set and the image segmentation method. Yeah, here the input is an image just as above, but the target is a mask, and that's also visualized properly. Even though, you know, the target is not just, the mask is, you know, has a different representation from the image. You know, this is the best way to visualize it. And this doesn't just work with the built-in helper functions used to create learning methods, but really, you know, any learning method that you create with a block-based interface. This is, you know, this is just a function. It's not actually like a custom struct, just to help you construct it. And this, you know, new API is also quite easy to extend. So here we can, this is the actual definition of how to show a 2D image to the text backend. I'll talk about backends in a minute. Data here is, you know, something that data for the block image. So there's an array of a matrix of colors, and then we use the image in terminal package to show that to some IO context. And then this will automatically handle, you know, putting it into a table if you have multiple blocks and putting the headers and everything on top. You really just need to implement this method to support like a new custom block type. So it's quite extensible. And then this patches on the show backend, which is a new distinction introduced, because I said earlier that Marquee is no longer the default for visualizations, and it's now the text backend. And yeah, I'll show below what all of this looks like in Marquee, but it's the same code, just using a different backend. But before that, I just want to quickly show, and this is actually the same as above, that you can create, that's also the same. Okay, there's another example with the multi-label classification that shows also all the tags, basically the same. And you can also use show block and show blocks, like without the learning methods, to basically create custom visualizations. So here we have some blocks. This is like a 3-tuple of an image, a mask, and a label. So it's, I don't know, you might want to use this for some task. It's not a standard supervised input-output task. And you can also see that we've named each block with this scheme where we have a string and then, you have a pair to the block. This is just creating some random data from the blocks using the testing interface. And then show block basically just takes some blocks and some data corresponding to that block. And then, we get this nice visualization for free, which is, random data, of course. But you can see the headers are filled in, and you can, build whatever visualizations you want with this. Show blocks is the same, but it just takes, a vector of observations for the same blocks, and makes it easy to show, multiple observations. And usually, if you import Markey or any Markey backend, then using requires.jl, FastAI will now switch the default backend that is used to visualize it. I'm using it, doing it manually here because I already had that loaded from the sys image. But then this is just all the same code as we had above, and you automatically get these visualizations with fishes that you can actually see are not completely pixelated. And in the same manner, we have the one hot tensor shown as a bar chart of the distribution, the probability distribution. Yeah, it can show a batch. So this is just the same as I was showing above. Here, also, comparing the actual encoded sample with the predictions, and the same for the semantic segmentation stuff. Multi-label, and then this is the example for the custom one. So for high fidelity visualizations, if you load Markey, it'll just be used automatically. But if you don't want the longer startup time, or maybe you don't need it right away, then the default text backend is going to save you some time. Yeah, that's basically it. There's some helper methods for creating visualizations directly from the trained learner, so that you can just run like show outputs for the method and the learner, and then it automatically like takes a batch and runs inference on it and shows you what it does, so you don't have to actually ever deal with like the data itself, like for the very high level use cases. And you can see that in the in development documentation in the quick start guide that's been updated. But yeah, that's basically everything that's new.
Thanks. Looks really awesome.
Are there any questions or any suggestions?
Looks nice. It'll be fun to play with a bit.
Sorry, what did you say?
It would be fun to play with it a bit before,
Yeah,
That looks really cool.
I'll post a link to this notebook later into the Zulip, and then all you need is the master branch of FastAI to try it out if you want to.
Seems like it would also be nice to integrate some of this stuff into some kind of Julia Hub tool.
Yeah, I mean this paradigm based around blocks, as a block being one modality of data, really is quite nice for all kinds of interfaces and all kinds of extensibility. If you've seen the discovery tutorial in the docs, where it shows you how just based on the blocks you can find different data sets that are registered, or how a lot of the convenience functionality is built around that. And that I also showed once the very basic no-code UI in Pluto that uses those methods to just make it really easy to construct a learner without writing any code. I think it's writing some high level software that's quite easy to use should be should be quite straightforward on top of this model.
Yeah, maybe a good like GSOC, JSOC style project.
Yeah.
Well, that's all we had on the agenda for today. Thanks again, Lorenz. Unless anyone wants to bring something up for us to discuss. I guess hearing nothing else, we can probably end early for today.
Yeah, that's from my everything from my side. This.
All right.
I also have a prototype working for the training loop profiler, but not something I can show yet. But that'll be interesting.
Yeah, that'll be interesting to discuss next time. All right. Well, thanks everyone for joining, and see you 2 weeks from now.
Yeah. Thanks, guys. Bye.